Bismillahirrahmanirrahim. Assalamualaikum and a very good day I bid to Dr. Kartini. We are from Group 5 and we will be presenting on our case study about chemical constituents from the stem bark of Closina excavata Bernfield. First, before we proceed to our presentation, I will introduce myself. My name is Nurul Izzah binti Abdul Hadi. My matrix number is 200549.
My name is Aina Afika binti Maidris. My matrix number is 200647.
My name is Nur Ala Naswa binti Muhammad Azman. My matrix number is 200,690.
Before we start with the plant taxonomy, I will brief about the Closina excavata. Closina excavata Bernfield is an evergreen white shrub that can grow up to 4 meters tall in height. It bears small yellowish flowers with green berries which turn translucent until its ripening. And it is widely distributed in China, India, and Southeast Asia, especially in Malaysia. In Malaysia, it is widely known as ceret hitam. And Closina excavata is found to have anti-inflammatory, antimicrobial, antioxidant, and also analgesic activities, which can treat colds and also stomach disorder. For the plant taxonomy, it is under the kingdom of Plantae, and in the phylum of Tracheophyta. Tracheophyta is a vascular plant, which is land plants with lignified tissue for conducting water and minerals throughout the plants. And it is in the class of Magnoliopsida, in the order of Sapindales, in the family of Rutaceae, which is it have flowers that divide into 4 or 5 parts, and it is usually have a strong scent. It can range from herbs to shrubs and large trees. And it is in the genus of Closina and also in the species of Closina excavata Bernfield.
Okay, for traditional usage of the plant, it can be divided into 3 parts of the plant, which includes root, stem, and also leaves. For the root, Closina excavata Bern-F has antibacterial activity with complete inhibitory effect against most microorganisms. The dried and powdered rootstock can treat decayed teeth. Closina excavata Bern-F powdered root can be used as poultice for sores, include ulceration of the nose. Decoction of the roots is drunk for bowel complaints, chiefly colic. Colic is a prolonged and intense crying of fussiness in a healthy infant. Next is stem. This plant stem can be used for the ailment of colic, cough, headache, rhinitis, sore, wounds, yaws, and detoxification in some countries. Closina excavata Bern also has inhibitory effects on tumor promotion against 12-O-tetradecanol-4-bol, 13-acetate-induced Epstein-Barr virus early antigen that activate in Raji cell. Let me tell you a bit about Raji cell. Raji cell is a lymphoblastoid cell with beta cell characteristic, which can lead to translocation of immunoglobulin gene. And the last part of the plant is leaves. This plant leaf give inhibition effect on rapid platelet aggregation, thus leading to vasoconstriction. Closina excavata Bern-F leaf also can be used to cure cold, abdominal pain, malaria, and also dysentery. I'll pass this to the next presenter.
Next, I will explain on the class of secondary metabolites of Closina excavata. Closina excavata have about 5 secondary metabolites, which is coumarins, alkaloids, triterpenes, sterols, and also xanthones. But in this presentation, we choose coumarins, alkaloids, and triterpenes, which is coumarins and alkaloids are the major secondary metabolites. In the coumarins is usually a benzene molecule with 2 adjacent phenolic substances that are composed of cis benzene and alpha phenol rings. And in this coumarin, we have clocinidine, xanthoxylidine, dentatine, and nordentatine. Meanwhile, in alkaloids compound usually contain at least 1 nitrogen atoms. And in the Closina excavata, it was found heptaphyllene, clausin H, and heptazoline. And lastly is triterpenes. Triterpenes, the secondary metabolites of Closina excavata, which is triterpenes, have a closinerins, which is a type of limonoids. Limonoids are highly oxygenated modified triterpenes that are biosynthesized from the acetate mevalonate pathways. Next is for the biosynthesis pathway.
Okay, next I will explain about the biosynthesis pathway. So as Isa mentioned earlier, there are three major secondary metabolite. The first one is alkaloid. So for the starting material is tryptophan, and then we convert into tritamine, and then we add sticrosidine to become tobersonin, and then it became deacetooxyvindoline, and then we convert into deacetylvindoline, and then we convert into vindoline, and then the tobersonin earlier also produce caterantin, and then caterantin and vindoline will add up to produce vinblastine, and with oxidation of the N metal will produce vincristine. Okay, so this is the biosynthesis pathway of coumarin. Cinnamic acid will convert into O-samaric acid, and then we convert into O-samaric acid beta D-glucoside. And then if we add HB or enzyme, it will produce O-samaric acid beta D-glucoside. And then it will become coumarin. So this is the biosynthesis of the hydroxycoumarin. The starting material is L-phenyl and L-phenylalanine. And then if we add PAL enzyme, which is phenylalanine ammonialase, it will become tranexamic acid. And then if we add C4H, it will become p-stomeric acid. And we add O2OH, it will become umbelliferone. And if we add 6OH, it will become ascolatine. With OMT enzyme, it will become scopolamine. And to the umbelliferone, if we add 8OH, it will become daphnetine. And then if we add SCOMT1 enzyme, it will become 7-hydroxy-8-methoxycoumarin. And then to the p-coumaric acid, if we add 3,3H, it will become caffeic acid. And then if we add OMT enzyme, it will become ferulic acid. And then if we add F5OH and OMT enzyme, it will become synapic acid. And then to this, if we add O2OH, it will become corresponding coumarin. So this is the biosynthetic pathway of three terpenes. There are two pathways. The first one is MVA pathway, and the precursor is acetyl-CoA. And if we add AACT enzyme, which is acetoacetyl coenzyme E thiourase, it will become acetoacetyl-CoA. And then we add HMGS enzyme, it will become HMG-CoA. HMGR enzyme will become mevalonate. And then we add MK enzyme, it will become MVAP, which is mevalonic acid 5-phosphate. And then we add PMK enzyme, it will become MVAPP, which is mevalonate diphosphate. And then we add PPMD, it will become IPP. And then if we add IDI enzyme, it is a reversible reaction, and it will produce the MAPP. For the MAP pathway, the precursor is pyruvate. And then we add 2G3P. And then we add DSS enzyme. It will produce deoxyxylulose 5-phosphate. And then we add DXR enzyme, it will become MEP. And then we add MCT enzyme, it will become CDPME. And then we add CMK enzyme, it will become CDPMEP. And then we add MDS enzyme, it will become MECPP. And then we add HDS enzyme, it will become HDMBPP. But if we add HDR enzyme to this, it will produce IPP, like in MVA pathway. So I will pass to the next presenter.
Okay, next is medicinal usage of secondary metabolites. As my member explained earlier, that we have three main secondary metabolites in this plant. The first one is coumarin. Coumarin is used in the treatment of prostate cancer, renal cell carcinoma, and also leukemia. Coumarins also have the ability to counteract the side effect that caused by radiotherapy. The next one is alkaloids. It is used as muscle relaxant in surgery. Alkaloids can also promote as chemotherapeutic agent in the treatment of many cancer types. It can be used in bronchial asthma. Alkaloid also has the ability to relieve discomfort of hay fever, sinusitis, and also common cold. Lastly, Alkaloid can be used in treatment of irregular rhythms of the heartbeat or arrhythmias. The last secondary metabolites in Clausena excavata BMF is triterpenes. Triterpenes can treat cardiovascular complications, tumor and cell proliferation, inflammation or hepatotoxicity. It also can prevent and treat against cancer and immunological disorder. Triterpene has potential in sustainably, which enhance human vitality and also promote longevity. And the last one, triterpenes are responsible for the reduction of bone marrow fat and the secretion of pro-inflammatory cytokines. Pro-inflammatory cytokines are actually involved in the upregulation of inflammatory reactions in the body. So it's good that triterpene help the secretion of pro-inflammatory cytokines, which can reduce the process of pathological pain in human. That's all from us. Thank you.